Hello, this is the review class for Math 1101, the last video I'm going to make. And before I start going through the questions, I'll just give you a quick recap on how the final is going to go. Okay, final exam, Saturday, 8 a.m. That's when you start the D2L quiz. The final is 10 multiple choice questions. You get them or you don't get them. You don't need to show me your work. Of course, they're long answer style questions in the way that they're written, so you should be doing workings for yourself, but the final answer is just a selection of a multiple choice. Besides that, you must be on camera while you're doing this test. And so I will have a Zoom meeting set up that you'll either be put into the male room or the female room. It'll be obvious which one you're going to go in, but you need to enter that Zoom room at 7:30. Okay, that's half an hour before it starts. And the reason that you have to come in half an hour before it starts is to make sure there's no problems. Okay, if there's a problem like the camera doesn't work and you need to get another phone, blah, 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 all that stuff needs to be worked out before you start because you only have an hour to do the final. All right, if you have further questions on the final, read the email. Please, please, please read the email. I've already sent it. I'll post more on D2L. And, you know, overall, please just relax, do your work, but I'm not going to give you new questions on the final. It's things that you've probably seen before in some way, okay? So without further delay, let's go ahead and get started. You don't have that's in our section. Yeah, let's go ahead and get started. So unit 6 and 7, I'm gonna start by going down. This is all on D2L, and it's just a review of the matrix multiplication. I'm gonna do these two questions. Actually, I'll do three, but mostly just the first two are important based on what we did yesterday. What is the product of the matrix multiplication? So if you know how to do matrix multiplication, this should be pretty easy. In fact, it should be very easy. You just give me the answer. We can see that this is 2 by 2. We can see that this is 2 by 2, which means it's allowed to be multiplied, and our answer will also be 2 by 2. And so what we get, we're going to get a 2 by 2 matrix. You just need to tell me what the 4 elements are. And the way we do this, we take the first row, multiply it by the first column, and remember we multiply the first elements of each. So in this case, we multiply x by x, or x by negative x, that would be negative x squared. And then we need to add negative y times negative y. So y squared. This is the same thing we did yesterday. You multiply one element at a time. Remember the thing I did with the calculator? I was like, okay, you have one row and you have one column. The elements of the column kind of fit on top and they just multiply on top of each other in a way. But you can review that if you need to from the notes. I'm going to do the first row times the second column. So that'll be negative x squared minus xy. Let me double check. xy, okay, the first one was wrong. I don't know why I thought that was x squared. So x times x times y, and negative y times x, which is negative xy. So Kevin, did you mean to raise the hand or did you make a mistake? Maybe you made a mistake. Let's keep going. We did this yesterday, so it shouldn't be a surprise. We're going to do the second row multiplied by the first column. Now we have, why is this showing up? Get out of here. Sorry, 1 second, my computer is freaking out as usual. We have negative xy plus xy. And then we have the second row, second column, which is y times y, or y squared, plus negative x times x, which is x negative x squared, so it's minus x squared. Okay, so what I've done, I've just done the same thing I did yesterday. If you have a row and a column, you multiply them element by element. And hopefully it makes sense what I did. Now we need to simplify this. Hopefully you'll see there's nothing to simplify here. So I'll write it like it is, negative x squared plus y squared. And in the top right, or first row, second column,
zero.
they can cancel. Yeah, they make 0. You'll see down in the bottom left, second row, first column, they also cancel, give 0. And then the last one, there's nothing to do. I'll put the x's first. But really, there's nothing else to do. This is my final answer. Okay. So I took this off a version of the final. This was a question on a previous file. If you have any idea how matrix multiplication works, in fact, if you understand how it works, there's no reason why you shouldn't get that one. All right. So any questions before I move on to the next one?
Clear.
Clear. Okay, I've got Mohammed saying it's okay. Again, it's just the same thing as we did yesterday. We're going to do one more now. And let's see, 2 by 2 times a 2 by 2 gives us a 2 by 2. So what we need to do in this case is pretty simple, really. We multiply it out. So I'll just tell you multiply. And then we're going to compare our answer to the matrix C. So just for clarity, I'll call this A, B, and C. I'm going to multiply A and B, see what I get, and compare it to C. You'll see what I mean in a second. The whole point of this question is to find X and Y. So let me just show you what I mean. A times B. If I multiply it the same way that I've been multiplying it. So first row times the first column. In the top left here, I should have 4x plus 0 times 5. So 0 times 5 is a 0, so I just have 4x. All right. If I do the first row second column, I have 4 times 3, which is 12. And then I have 0 times -1 is 0. So I'm going to do now the second row, first column, or for whatever, I'll do second row, second column since I'm on it already. That'll be a 6 plus a -y, or -1. And now I'll go back and do the second row, first column. Remember, if I'm looking at second row, first column here, it relates to the second row, first column of my answer as well. So I'm actually looking for this bottom left space. So this is what? Someone tell me what it is, just so that I don't feel like I'm doing all the work here. What's our left second row, first column going to be?
2x.
2x. 2x. 2x and what?
Plus 5y.
Plus 5y. So Mohammed gave me half of it. Notice that you need to have 2 and x multiply, but then y and 5 multiply, because you do the firsts and then the seconds and the thirds, if that makes sense. So what I said to do is do this multiplication, and then we need to compare it to C. So let me show you what that means. AB is this answer. So I'm going to write out the answer. I'm just stealing that from above. A and B is this, and this is this. So let me show you what I mean. Compare your elements.
X is 9.
4x, yeah, exactly. 4x is 36. So that's a really easy one to get. 4x must be 36 because those matrices are equal. That means x equals 9. Now let's look for another way to figure this out. It looks like here, 2x plus 5y
Y is 7.
3. Yeah, you're way ahead of me, right? This would not be the best way to do it. We can see here that 6 minus y equals -1. So that would be a really easy equation to solve. And so I'll write that out here. 6 minus y equals -1. Once again, these are the blues. This is the other color, whatever color that is. And if you solve that, it means y equals 7. So this is the kind of difficulty of question that you'll be expected to do. Why can't I make a box? That you'll be expected to do pink. Why couldn't I think just, of course it's pink. I'm stupid. Pink. This is the difficulty of question that you should expect, okay? For this unit. I'll either give you one like the first one, or maybe I'll give you one like the second one. And like I told Zara yesterday, I think, Zara, you're the one who didn't have a calculator, right? You didn't need a calculator to do this. You just need to understand how matrix multiplication works. Okay. Any questions on this before I move on? Why did I do 2 of them only? Okay, well, so Ibrahim, why did I do only 2 of them? Well, because the whole point of the question is to solve for x and y. So let me use some other obvious colors here. I know that based on the way I've set this up, 4x is 36. So I can easily solve
أفندم أنا جيم.
12
لسه
is
هو
of course
ماما
12.
لسه هو احنا عندنا يعني ال8 وحدات اللي احنا خدناهم مراجعة. أكلت.
Okay,
خلصت كل حاجة والله ما تقلقيش يعني.
it's okay.
حاضر. سلام.
You could mute your microphone up though. Okay,
sorry.
yeah, all right. Just hit mute next time. Can't even talk over you. Your voice is so intense. Okay, did you catch what's going on, Ibrahim? I'm only looking for x and y, so I just took the elements that I needed. Okay, solve for x, y, and z using matrices. I'm not going to solve this whole thing. I just want to remind you how you would. Long
ما
story
بتقول
short,
لك اصحى عايزاك وصحي بتول وانزل لها.
I'm going to throw you up into space. Just use a calculator. So x is A inverse C. And all you need to know is what x is. Okay, x is the x, y, and z values. A is your coefficients. So it's the numbers in front of your variables. So in this case, 1, 1, 2, 1, -1 and 1, -3, 2, and -1. I would need the inverse of that. And then my C matrix is the answers on the other side, -10, 3, and -6. Okay, this is our X matrix, this is A inverse, and this is C. And all you do is multiply them. Multiply the inverse with C on the calculator, which I showed you how to do yesterday. And what you end up getting is the answers that I put there. Okay, you get -2, 1, and 3. So just to be crystal clear here, this step here is just calculator work. I wouldn't probably ask this on the final, but matrices tend to come up in the future. So I just wanted to have one last example there. And to write out the final answer would be this. We can see that x at the end of the story must be -2. We can see that y must be 1. And we can see that z must be, 3. All right, and that would be our final answer. I did that yesterday, but again, I wanted to give one last example now you've had time to sleep on it, let the information save in your brain a little better. And you can see that what I did yesterday hopefully is not that bad. So that's the last thing we're going to do on Unit 6 and 7. Do you have any, Unit 7. Any questions on matrices you want to ask before I move on? It's cool, I'm cool, everybody's cool. All right, just as usual, just say, sir, I don't have any idea what's going on. Just give me one more example, please. Well, this one, I only need one. Okay, Unit 6. Students usually find this confusing until they don't, and then they're like, oh, wait, this is really easy. So let me just quickly show you what this little box is. It's summarizing everything that I think is important about curve sketching, which is slopes and concavity, second derivative. So let's look at this. First derivative is slope. All right, first derivative, another word for first derivative is slope. And just allow me to look at these two curves first, okay? If you had to look at those curves, if you were to look at the slope, hopefully you would notice that the slope for all of these is positive. Yeah, it's going uphill. You're going this way. So no matter where you put the tangent line, it's positive. So the slope for all of these is positive. All right, if I put a tangent line here, it's positive. I can put tangent lines here, it's also positive. All those lines are going uphill. So the slope is positive. We can also say that the first derivative is positive. We can say that the function's increasing. They all mean the exact same thing. right? On the other side of this, the slope is actually negative. And the reason we know that is because everything's going downhill. So no matter where I put the tangent line, it could be like this, it could be like this, it could be like this, or it could be here or here or here, whatever. All of those are negative slope. They all basically look like this, right? At the end of the day, is it like this or is it like this? Well, it's downhill. From left to right, it's downhill, decreasing, okay? So these basic ideas are very important. They tell us what the sign of the first derivative are. So long story short, f prime greater than 0 means f prime positive or slope positive. F prime less than 0 means slope negative or the function decreasing. They all mean the same thing. Next, let's talk about concavity. Let's remember here that if it's concave up looks like this. Do you remember? Concave up means second derivative positive. If you were here for that class, you should remember. We clearly can see it from this part. And then if we were to continue it, of course, it's like half of a bowl, right? Half of a skate ramp or whatever you want to call it, right? Half of a curve. So both of these are kind of like parts of a upward curve, which is why its second derivative is greater than 0. Or we can also say the second derivative is positive. We can say concavity is up. It all means the same thing. And just to finish this story, concave down means you have a curve that has it looks like this. And of course, these are both part of a concave down curve. All right, so I just wanted to summarize all the ideas in one place that we did. These are what came out of our number lines when we made our number lines. So you might wonder why I'm giving you like this cheat sheet. Well, the questions that follow use these ideas. And I'm sure that by the end of this page, you're going to have a very clear idea what the heck I'm talking about. Okay, so if you need a reference, this is your reference. Let's do some questions so you can see what I mean. So it says, check your understanding. Describe the graphs below using the first derivative and the second derivative using the following terms. So we either say f prime is greater than 0 or f prime is less than 0, or f double prime is greater than 0 or f double prime is less than 0. Remember, this is talking about slope, and the next one is talking about concavity, the curve style. Is it down or up? So let's talk about this. Let's do the first one. It's talking about this interval. Interval means the area. So from negative infinity to 0. So it's talking about everything before 0. So look at the left side of the curve. Is the slope positive or negative in that region? Just the slope.
Negative.
Try again. The slope is positive because if you draw lines on this curve right now, that would be a positive slope, positive slope, positive slope, positive slope, positive slope. It's all positive slope. You see what I'm saying? Ibrahim, did it finally just click for you what I'm saying here? I know it clicks eventually. All students get it at different times. So this is positive slope. I could, the slope is going uphill. The function's increasing. It's getting bigger. The numbers are getting bigger. For the second derivative, so let me write this. So if the first derivative is positive, it means that the first derivative is greater than 0 on that interval. For the second derivative, does it look like, say again?
Concave down.
Concave down, yeah, concave down. Because it looks like part of this curve. And so that one's pretty easy. Once you see it, it's impossible not to see it. So it's part of that downward curve. So that one should be pretty easy. Let's look at the next interval from 0 to 3. So we're talking about from 0 to 3. I'll look at this part of the curve here. Concavity is really easy. So it's definitely downward, negative. The second derivative here is negative. And I'm assuming, Mohammed, you were talking about less than 0 for the slope. So the first derivative is also negative, less than 0. We'll compare these again back earlier. In fact, I'll compare it now. Let's look at this part up top. it's both negative, slope negative, concave negative. It looks like this case, doesn't it? Doesn't that look the same? This and that? And it says concave down, negative slope. It always looks like that. So if you need to, you can memorize those four, but I don't recommend it. It's just a way to check your answer. Let's do another one. On the interval 3 to 4, which is just this little piece here, we're talking about this. This one's a little tricky. Is that concave up or concave down? If we look right in on it and pretend we didn't have anything else, you know, pretend the rest of the world doesn't exist. If you had to choose if it was going up or going down, this is definitely concave up, because it would look, it's like part of this. In fact, that whole section is going to be concave up. Do you see what I'm saying? If you look at it carefully, just this section, you can see that it's actually concave up. It's not curving downward like that. So I'm doing the concavity now. It's positive. So F double prime is positive. What about the slope? Is it going down? Is it decreasing? Are the numbers going smaller? Or are the numbers getting bigger? Well, the numbers are getting smaller. It's going downhill. So we have first derivative negative, where the slope is negative. The first derivative, negative. They all mean the same thing. So once again, we just said slope negative, concave positive. What is that supposed to look like? Slope negative, concave positive. It should look like this, which it does. That's exactly what it looked like. So we can compare these things, and you can see, hopefully, that I'm not lying to you. This is how it works. Let's do the last one. Tell me what the last one is. What's F prime and what's F double prime? I want you to give me that answer. So Muhammad Al-Malki is saying it's double prime greater than 0. I agree with you, because it looks like half of an upward curve. It looks kind of like a curve like this. And what about the slope?
Positive.
Positive. Yeah, it's going uphill. It's increasing. If it's increasing, we know the slope is positive. It's not always so easy to see. In these, it's not so bad. Okay, so two positives again. We didn't actually have two positives before. We had two negatives, so it's kind of like the opposite. This is positive. So if you want a cheat sheet, you know, positive slope looks like this. Negative concave looks like this. Negative slope looks like this. Negative concavity looks like this. Negative slope, positive concavity, positive concavity. You put all those ideas together and you can start building pieces of the curve. You see what I'm saying? So this is like your ultimate cheat sheet for the one question you're going to get on it on the multiple choice. Why did I make this? Why am I going through this? Because I want you to do well. So I know what's on the final. I made this for you. What do you think you're going to get on the final? Probably a question like this. Okay? So if you're here, you're watching the videos, everything else, you should be pretty good. Should be fine with this. Let's do the last one. And then we'll move on to the kind of full review. No problem, Hamza. All of this is one big hint, or I wouldn't have made it for you. I made all these worksheets. Okay, let's do this. So on the interval from negative infinity to a, it's not a number, but who cares? Let's see, from negative infinity to a, what does it look like? It definitely looks like a downward curve, so I can do my concavity already. It looks like this, and it's decreasing. So it looks kind of like this at every point. No matter where I put the tangent line, it kind of looks like that. So my slope is less than 0. Okay? Wait, Ali, you have a question for me? So this is, yeah, maybe you weren't sure which one I was talking about. Yeah. In the next interval, a to 0, which is between where I just talked about and the 0 point, That one's a little tiny piece, but definitely concave up. So it looks like part of this. And the slope definitely positive, going upward, yeah? Slope kind of looks upward. You need to look at it closely, but the slope definitely is going upward. And the concavity definitely could be part of this curve, right? You just need to get the basic idea and then you'll be okay. What about from 0 to B? Mohammed's just on fire today, apparently. You must have, I guess it clicked for you. Let's see, you have positive slope, positive concavity. I don't agree. So you got one mistake. This one's positive slope for sure on that interval. We're looking at this interval. The slope is definitely up, but it's more of a downward curve. Yeah, you caught it. It's part of a downward curve, so it's negative. Be careful with that one. That one tricks students quite a lot, actually. And the last one is the last chance for you to impress me. What's the last one going to be? What do we think? Mohammed thinks both negative. What do the rest of us think here?
concave down, slope negative.
Try again.
Actually, both are positive.
Try again. If you're not sure, like this is what I do when I want to know what the tangent line is. I put my ruler at a point, match the curve, and I'm like, all right, that's a tangent line. That's a tangent line. Are those slopes positive? Are they positive slopes? No, they're down. That means negative slope. So if they're going from left to right, if they're going downhill, that's a negative slope. So it definitely can't be positive slope. Let me make sure that I've got rid of that. Okay, so that's definitely negative slope because no
Concave.
matter where you draw the tangent line, it looks like this. And then what's the concavity? I'm seeing a lot of concave up.
Up.
One's concave up and the slope is down. Yes, it's concave up because you can imagine this continuing and coming up like this. That's definitely concave up. Or think concave positive. The same thing that I say in my physics classes. If it's concave up, positive, well, it looks like a smile, part of a smiley face. That's positive, right? A good thing. Positive is a good thing. So these are all related. It's related to the A value, but I won't get into that. All right, so hopefully that's becoming clear. I mean, students look at this page and they're like, I'm dead, just kill me now. But hopefully now that you've seen it, it's more clear. So just so that we have full notes, I'm going to jot this down. This is slope positive. This is slope positive. This is slope negative. This is concave down. This is concave up. This is concave down. Sorry, I didn't kind of ran out of space here. And this is concave up. All right, and you can compare every single one of those back up top and see what's happening. Just take a snapshot of the curve, right? So if you wanted to know just this one, you can just redraw it to yourself and say, all right, well, the slope is definitely down because the function's going down. The easiest way to know, is it going down on the page, from left or right? Is it going down? Of course it is. So the slope is negative. And then does it look like a happy face or a sad face? If it looks like part of a sad face, which it clearly is, it would be negative or less than 0. They mean the same thing. So, take some time. If it's not perfectly clear, go back through it, try to do it again from scratch and see how your answers compare to mine. And eventually you will get that. You will understand. Eventually. The last thing I'll say about this before I do the rest of the review, I want to connect it to what we were doing in class. I'll do the first one. No, I'll do this one. So in class, we were doing things like this. We were marking down like A and B. We were marking things on the number line. We were saying, what about the slopes? Well, this is what we were doing. We were saying this region's negative, this region's positive, this region's positive, this region's negative. And if we were to do the concavity, we would say this region's negative, this region's positive, negative, and positive. So that's what it means. That number line is what we've been doing. They mean the same thing. If we're given the graph, we don't need to do the first and second derivative test. But if we're not given the graph, we do have to do the second and first derivative test. So lots to take in. I know it's not clear for everyone, but I feel like I've done enough examples now. Now it's just a matter of going back through this, making sure you have the practice. So are we clear enough so that I can work through the other units 1 to 5?
All clear.
You don't have to be a master at this. I mean, your exam's not until Saturday. I know you're busy people. I know you have other things going on, assignments, tests, everything else. But I'm not going to give you anything you can't handle. Or at least I'm certainly not going to try to give you something you can't handle. Let's do this review. This is on D2L. I want to be clear about that. This is all on D2L. I'll put it on the front page. Just look around on the front page until you find it. It's right there. I also put it in the WhatsApp chat. So if you don't have that already, please go find it. But I'll just do it for you and, do it as you like. So would you like to start with a particular topic, or would you like me just to go from start to finish? To me, it makes more sense to go from start to finish because it's the furthest stuff to the closest stuff. But if you have some preference, this is the time to let me know. Start at the start.
Start as you want.
You forgot half of these. Yeah, you'll remember. I am very sure that you're going to remember this. So it says it wants the complex cube roots of this in polar form. So first things first, we're going to end up using what's called de Moivre's theorem, which you might remember. It has to do with polar form and exponents. So let's just get to the main points. I have the number negative 27j. That's a complex number. And the question is, it wants the cubic roots, the cube roots. I need to do two things. I need to make it into an exponent, or in other words, I need to make it into power form. So I'm going to make it power 1 over 3, and that'll be negative 27j. That's the first thing I need to do. And I need to change it to polar form, which is actually very easy, but also if you don't review it, it's going to be hard to remember. So in rectangular form, this is our number. In polar form, does anyone know what that number is? Does anyone remember? I'll draw you a little sketch, but does anyone remember? It's 27 something. What's our angle? 90? Not 90, but you had a good shot. It was a good try. Not 90, it's actually 270. I'll show you why. You need to remember that this axis is the real axis, and this axis is the imaginary axis. If you have any j's, it goes on that axis. If you don't have a j, it goes on the real axis. So we have a j and it's negative, so it's down. So long story short, this is our vector, this is our 27, and you measure from here. That's our 27. Mohammed, you're saying, yeah, you have the 4 angles thing? You do, but I'm not going to give you anything you need to use tan on. I'm either going to give right, left, up, or down, okay? So speaking of which, this is a good chance for me to show you the other cases. Let's give you 3 more examples of how you'd find rectangular to polar. So for example, let's just say we had a positive 27j, or make it a 10j, okay? We want that in polar form. How would I change that into polar form? Well, first of all, we need to know that it's rectangular, so let me move it down. If we're given this in rectangular, what is it in polar form? Does anyone know it already? It's 10 something. J is vertical. Remember the imaginary axis is up and down, so it's actually straight up, maybe 90 degrees. And the reason for that is if we draw it, it's 10J, which means 10 in the J direction, which is up and down. It's positive. So 10, and then our angle is 90. So that's where that comes from. Good job, Zara. I see that. Let's try another example. And these are just off the top of my head. Let's just say you're given rectangular form, the number 3. What would be the polar form of the number 3? Well, it actually doesn't have a complex component. So it's actually 3 and 0 degrees. So if you already knew that, yeah, if you thought about that and you got it, that's great. The reason for it is it's a real number, so it's on the real axis, and it's not negative, so it is what it is. The angle is 0. Nothing else to do. That's just the number 3, 0 degrees. There's only one other case that you could get. Again, I'm telling you, I'm not going to give you something that needs tan. So what is the missing case? So far, I've had a negative complex, a positive complex, a positive real. I'm missing a negative real. So I'll say -4. So what's the polar form of -4? It's 4 angle something. I'll draw it on the axis. If you already know it, then you can tell me. It's the only angle I'm missing. Ibrahim, you're saying, how do you know if it's up, right, left, or down? I'll answer that when I finish this, okay? Let me just get this done. I can answer part of this in that question. This does not have a J part, so it must be a real number, which means I just go left. The negative means left. And then this is our 180 degrees. So Ibrahim, it's okay, Kevin. We'll see you later. Definitely watch the videos because I'm going to be going through a lot of really, really key stuff. But peace. It was great to have you in the class. I probably won't see you again, except from the Zoom, of course. But good luck on studying, okay? We'll see you around. Ibrahim, let's try to make some connections here. This is a complex. Our complex axis is our up and down. So if it's a positive complex, you go up. If it's a negative, you go down. That's all there is to it, okay? So look, it's a positive 10J, so we go up. If it was a positive real, we go right. If it was a negative real, we go left. If it's a negative complex, we go down. You see how this is all coming together? Hopefully so. Now, what was the original question? We begin from the right angle. We begin from what's called the positive real, or we start from the right, and we just go from there. Right? You'll always start at 0 this way, and then you go around like that. All right. What was our question? We needed the cube roots. I'm sure that once I start writing this, if you don't remember it already, you will remember it. We're trying to get the cube roots. So we need to write down our polar form, and you need the cube root. And we're going to use what's called de Moivre's theorem, which takes the exponent, puts it on here, and then we multiply it by the angle. So it looks something like this. 27 to the power of 1/3, and then it'll be 1/3 times 270. You remember this? 1/3 of 270? It should start ringing some bells. I know you've done it. You had it on the assignment, the very first assignment. So we're seeing it again at the end of the course. And if you solve this, it's 3 and 90 degrees. Mohammed, what's your question? Is it 3 answers then? Yes, it is. Because the next thing we're going to do, we're going to add 360 to this angle, and we're going to get a second answer, and then we're going to get a third answer. Yeah, that's exactly right. So the key is if it asks you for cube roots, it means that it's getting a third root. If it's the number 3, you're going to get 3 answers. okay? If it was square roots, you'd get 2 answers. If it was 1/4 roots or 4th roots, you would get 4 answers. I'm just going to give you 3. So let's go through this process again. 270 plus 360, 630. And the exact same rules apply. You don't need to write out every step. I write out every step because I have a tendency to make little stupid mistakes that I can't find later. So I learned to show everything, then I can find my mistakes. Something theorem to Waber's theorem. What you get is 3, and then what's 630 divided by 3? It's 210. So we'll do the next step again. I'll give you a small tip if you want to do this fast. We can jump straight to the next answer because 90 plus what is 210? Well, I just subtract them. It's plus 120. So to get the next one, you would add another 120, and it must be 330. I'll do the rest, but the pattern is solid. We already know what the answer is going to be. So just something to keep in mind. I'll do it all out just so we have full notes, but we already know what the answer is going to be. You can do it both ways, the short way or the long way. I'm sure most of you will want to do it the short way. Okay, 27. You don't need to show every single bit. I just want you to have the workings. And now we have 3. What's this? 330. So do it whichever way makes you happy, okay? So we added 360. Yes, exactly. So that's what I wrote here. The 360 every time. When I said we add, yeah, I guess. Okay, yeah, sorry. I didn't see your question, Ibrahim. Thanks, Mohammed, for answering that. Long story short, you'll be given something. It'll either be a real number, positive or negative, or it'll be a polar or complex number, positive or negative. So you have 4 possibilities here. You change them to polar form, you just stick it into this recipe, you bake your cake, and you eat it for supper. Anyway, I got lost in that metaphor. You just take polar form, go through these steps, okay? Just go through the steps. You'll be fine. Just notice that I'm copying this here and I'm putting it into here. They are the same thing. And go through the recipe. Okay, these are our final answers. And I've put all the answers here for you to check. So I got my own questions right. So I feel pretty good about that. All right, shall we continue? All right. Just tell me if you need me to slow down. We've got lots of time. Unit 2, functions. So you might not remember Unit 2, but you probably didn't remember Unit 1 either, and now you remember some of it. You don't remember all of it, but I'm focusing on things that you should really remember how to do, okay? Key ideas. I'm not covering every single thing that's going to be on the final. That's not happening right now. So don't get that in your head. Don't think this is the only thing you need to study and you're going to be fine. This is just a helpful way of me helping you with the final, all right? Let's read the question. For the function y equals 7x minus 12, what will be the equation of the new function after a vertical translation of 4 units up, a horizontal translation of 1 unit left, and a reflection through the x-axis? So I want to remind you what all these things mean. A vertical translation of 4 units up, okay? We need to do 4 up. We need to do 1 left. And then we're going to have a reflect in the x. And let me show you what these mean, okay? 4 up means that your y will turn into y minus 4. 1 left means that your x will turn into x plus 1. Remember your opposites. And if it's reflected in the x, that means that in the end here, your y is actually going to get a negative in front of it. Okay, so let me show you what this looks like, and you'll probably remember it as we go. So I'll write out my original question. The first step, I'm going to be translating things. So my first step, I'm only worrying about translations because it says then the reflection through. I'm going to translate it first and then I'll reflect it. That's just my personal choice here. So this is the original question. I need to do my y thing. So I'm going to say y minus 4. If I see x, it needs to turn into x plus 1. So I'm adding the 1, minus 12. Okay, that's all the translations are. If it shifts it right, you subtract. If it shifts it up, you subtract. It's opposites. You get the idea? If it says up, bring it down. I know it sounds counterintuitive, but that's how the math works. So I need to solve for y now. So I'm going to expand 7x and 7, so 7 times x and 7 times 1. Then I'll have a minus 12 still there and add the 4, and this will give me my y. You should be working this out yourself to check my work, and you should get 7x minus 1. That is not the answer. The answer is negative 7x minus 1. So something's missing. What did I miss? Well, actually, of course, I need to still do the reflection.
So all divided by -1?
Yeah, you can divide everything by -1. I like to think of it as multiply because in my brain it makes more sense, but you do whatever way. The second step is reflect. Do the reflection. So the way I think about this, take your equation, just put the negative on the y, and then you divide everything by that, or multiply, as you like. I'll show you both ways. So you could divide everything and change all the signs. I like to write it this way, and I'm going to show you why. If you move the sign to the other side with all the math with it, with all the 7 and the 1, all the terms, bring the negative there, you can see with the bracket you've got to multiply by everything. Some students just multiply 1 or 2 of the terms. This multiply means we do it on everything. But at the end of the day, really what you're doing is just change all signs. That's really what we're doing. So whatever way you want to put it, there's many ways to describe the same thing. You're going to get this. Okay. If you look at this, you take this, change all the signs, you get a negative 7x plus 1. It's the same thing. I just wanted to show you all the work. May I know why you multiply it by negative? The reason you multiply it by negative, Mohammed, is the rule. If you're reflecting in x, you have to multiply the y by negative. It's our rule. All the y values, because remember, we've got the x-axis, all the y values turn into a negative version of themselves. They flip over the axis. And so we have to just do negative y. You get the idea? All the y values switch position. If there's a reflection in y, what we do is we do the exact same thing, but we change the x. So I'll give you another example of that. Let me shrink that down so I have a bit more space. And then I'm going to give you an example because that's a really good question that you asked, Ibrahim. Let's just say you had y equals, let's just say we started with this and I wanted you to reflect it in the x. What you would do, because you're reflecting an x, instead of taking, reflecting in y, sorry, you want to reflect it in y, change all the x values. So your x now turns into negative x. So just to be clear here, you're adding a negative in front of the x. Nothing else changes. You don't change the sign of everything, you only change the sign of the x. Okay, which is not the same function. Clear? No problem. Any questions you have, you ask them. This is why you're here now, is for me to help you. I don't need to do a review. I'm doing it because I care about you getting higher marks. So ask me whatever you have. You had a question, Abda?
No, all good.
Okay. Anybody else before we move on? We won't come back to this, so. As I drink my extremely cold coffee. So the applied problems you're talking about, you mean this, Mohammed? Like a question like this? All right. So what I'll say is I'll do this question. It'll prepare you pretty well for the types of questions you see on the final. It's not the same question. but it'll be similar. It's okay, Hamza, if you have to go. You can watch the rest of the recording later, but thanks for everything. It was nice to have you back in class, and hopefully we'll see you back on campus soon, all right? Okay. See you later. Take care. So, Mohammed, the big idea with these questions, especially the types you'll see on the final, you'll usually have two things, two formulas, a volume or something like it, and then an area. You'll be given information about one of them, which you use to solve for the other one, okay? It'll become clear what I mean when I do this problem. If it's not clear at the end of this one, we'll do another one, all right? Let's do this one. So it says a right cylinder, which is clearly what's written here, has a volume of 1,000. So I'm actually gonna write that down right now. Volume is 1,000. If I need it, I'll use it later. It says determine or figure out the surface area of the cylinder as a function of the radius of its base. So what we're really looking for here, we're looking for area as a function of radius. And in other words, we need the area, what's the best way to put this? We need the area formula, but we're only allowed to see R. So we need area in terms of R, no H allowed, okay? And what I mean by that will become clear in a second. I'm gonna write out the two formulas that are related to cylinders. You know, the key words here are volume and surface area. Now, I don't expect you to know what all the formulas are. I will give you a formula sheet before the final. It's actually already online, but I know what the formulas are, so I'll write it for you here. What are the volume formulas and the surface area formulas for a cylinder? You just write them out. You might not know what to do with them yet, but write them out and it'll help you figure it out. The volume of a cylinder is pi r squared h. You would get that from a formula sheet, all right? The area or surface area of a cylinder is 2 pi r h plus, 2 pi r squared plus 2 pi r h. Are you following me so far? I just wrote down everything I knew and
All clear.
volume and surface area. So now I start figuring out what I need to do. Well, I know I need area, but I need it in terms of R. It says that in the question. And it says, I can see right here that there's an H. So all I need to do, I need even this H in terms of R. If I can replace it with something in terms of R, I'll be good. How do I replace it? Use the volume formula. Use the other formula. That's usually how it works. So let me show you what I mean by that. I'm going to start here. Number one, maybe I'll make it blue just so that it pops out more. The first step here. What do I know? I know that volume is 1,000. Volume's 1,000. I don't know anything else about the right side, but I can now solve that for H and put it into the area and I'll be done. And yes, you will divide because we're looking for H only, so divide both sides by pi r squared, and you end up with H in terms of R. You see that? We have R there. If I sub it into the area, I'm going to have what I need. This is H. Take that, replace H, substitute, cancel some stuff, we're done. We're done this question. So the second step here, area, it'll actually be in terms of R, I know that already. 2 pi r squared plus 2 pi r, and now I'm going to substitute my H, which I just found, given the information, okay? And what we'll see is now it is all in terms of R. Or in other words, it's a function of R, which is the question. It says we want the cylinder as a function of the surface area as a function of the radius. We have the surface area as a function of only the radius. It is the only variable. There is no H. So that's what it's looking for. As long as you've only got the variable R, you're good. The only thing left is to do some cancels. So let's cancel pi with pi. You can cancel one of these r's with one of the r's on bottom. That'll leave one r. And then we have our answer. This is 2 times 1,000. 2,000 is our final answer. Okay, hopefully that's clear. I'm just going to move things around to make it more clear on the page. Oh my goodness. But if you need it clarified at all, you let me know, okay? All right, I'm glad. So Ali, you say, oh wow. What do you mean by that? Is it? Yeah, absolutely. They are harder under stress. And part of it is that you go into a test and you don't know what you're going to get. And then you see a question that even if you've seen it before, you haven't seen it quite this way. And you're like, oh, have I seen this or is it different? Is there a trick in here? What do I do? And you get all stressed out and you make stupid mistakes. And you're human. That's what happens. I was really bad for that when I took tests. I still take tests. I still do stupid stuff. But I understand. And unfortunately, there's nothing that I can say or anyone can say to fix that. All I can say is do as much practice as you can. And just do your best. The more practice you do, the better prepared you're going to be. But even the best students are going to get a point in the final where they feel like they've never seen it before. And you just need to sit down and relax and just think through it. You have the time. Even though you can't go backwards through the questions, take your time, be careful with your answers, know that you've seen something like it before, and just do your best. And if you can't do it, whatever, throw a mark away. It's not, no one's gonna not hire you in the future because you lost 2 marks on a multiple choice test at the end of a term back in 2020, all right? So your life does not depend on this. Do your best, you've already been doing great. Why would you not still do great, all right? Just, you're gonna be fine. Do your best, try to relax. If you can't relax, I don't know, have someone to rub your back or something while you're doing the test. Get your face mask on, I don't know. All right, let's move on. Conic sections, you remember this thing? Are the questions in order from 1 to 7? Unfortunately not. So I'm probably going to upset you, Abdo, but there's 2 important points. There's 7 units actually in 10 multiple choice. You can't go back and the order is mixed. So you could get unit 7 first, just by random. Every student will have a different order. But do you honestly think that you're going to look at a question like this and say, oh man, what unit is this? It's not going to happen. Who cares what unit it is? You're not going to get confused by that. Or you look at this question. Do you think that something talking about an ellipse with standard form, you're going to get confused by that? You won't. It's obvious. Do you think that the trigonometry you're going to think is derivatives? No, you're not. Do you think that in derivatives you're going to think that this is something else? No, you're not. So don't worry too much about that. It's annoying, but it's not going to make or break your success. I'm trying to make you feel better, but I am telling the truth. It's not going to make or break how you do on this. How you do is going to be based on how much work you've put into it. That's the most important part. Okay, so let's continue this, because anyone watching this video is going to be like, okay, stop with the motivational speaking. Please tell me how to do the math. And that's what I'm going to do now. So what are the coordinates of the foci for this ellipse? We're only going to do, a couple questions on this actually. So an ellipse, something you need to remember is the foci, or this is the major axis because it's the biggest axis. The foci will be somewhere in here. They're somewhere along the major axis. Let me label the shape first. The major axis, the distance here, this distance is A. That distance is also A. The vertical distance, you'll probably remember, is B. And this distance is also B. And something else you might want to remember, A in this case is going to be the major axis. B is the minor axis. Comes first. You might not need this. Comes second. All right, so some things to remember. You're saying focus is 2, focus -2? No, it's not, but good try. Let me try to remind you what else we need. The 3 most important things, in fact, the 4 most important things are these. Center. The center you get for free. Where is the center? It's literally in the center. It's -2, -1. Okay? And we know, let me draw you a little picture here. You should know that if we have our center down here, and we have our axes like this, or minor and major axes, if our center is in the middle, our focus is going to be somewhere over here, and it's going to be some distance, c, from the center. But I'm getting ahead of myself. Let me show you the other pieces. What's A? A is the length of the major axis, or at least half the major axis. It's half of this. What's that distance? It looks like 1, 2, 3 to me. A is 3. 1, 2, 3 on both sides. So A is 3. And I'm going to square it because we always like to get the squared answer, A squared. B is the half the length of the minor axis. So how big is it? It's 2. That means that B squared, why did I put 4? B squared is 4. Exactly, Mohammed. Our C value, let me move this away. Our C value, or our C squared, is A squared, and B squared. Is it plus or minus? It's minus. Yeah, so Mohammed, you remember it. It's A squared minus B squared. Hyperbolas are plus. That means that C squared is 9 minus 4. I already have these. Or if you solve that, it's root 5. Okay? So Ibrahim, you said B is from where? You're asking where is B from? B is the minor axis, which means the smaller axis. And B is the distance from the center to the edge on the smallest axis, which in this case is 2. See the distance of 2? It's 2 there. Okay. Just like A is the distance from the center to the edge of the major axis, which is 3. So that's 3 here. That's 2. I'm trying not to draw too much on the diagram because the more I put there, the less you're going to look at it, because it makes it look confusing. Okay, so that's not the point. The point was to get the foci, but the foci is easy. You take the center and add to the major axis. So we know the center is at -2 and 1. You need to go in the x direction from it. We can see that from here. You need to go left and right, so you affect the x. So you have to go plus and minus x from the center. Or in other words, let me just show you another way of thinking of it. The center is at -2 and -1. The c value is -2 plus c, and -2 minus c. That's our focus. So -2 plus c, the y value stays the same, and -2 minus c, or -√5 minus 1. That, I'd say, is one of the harder questions, possibly the hardest question on this worksheet, because students are really awful with these shapes sometimes. You'll notice that this is C. Okay, so the trick is, remember, this is the reason we add it to the x value is because the foci are along the major axis. So, sir, how can we find it in the graph? You can't find it in the graph really, because we just know that foci are along the major axis. So I'm actually going to erase some of this. Foci are somewhere around here and there. They're between the center and the edge of the major axis. So let me draw you a couple pictures. For example, if you had an ellipse like this, you'd have your major axis. The foci would be somewhere up there and there. So you'd have to add it to the y values. If you had an ellipse like this, which we just did, we would have our major axis this way. Once again, we would have to add it to the x values. So you take the center, which is of course at the center, and whatever the x value is, you add c or subtract c. If you have the center for a vertical one, you take the y values of the center and you add or subtract c. You'll notice in my case, I had to add or subtract it from the x values. Is that clear? I don't know how else to answer your question. Okay. So that's the idea. And there's only two cases. It's either going to be stretched vertically, which means your major axis is vertical, or it's going to be stretched horizontally, which means your major axis is horizontal. It's not easy. I'm not going to pretend it's easy, but at least I'm giving you another suggestion as to what you should study. So Ibrahim, you say, what's the difference? What's the difference between what? Between these? The difference is one is stretched up and down, which means that the foci, the focal points, are going to be up and down, which means instead of, you know, when we did the focus here, we had to add c to the x values. If it was vertical, you would add c to the y values instead. So you would have something, don't write this down, but if it was vertical, you would actually keep the x value and you'd have -1 plus root 5. You would have to actually add it to the y value instead, not the x values, because the long axis. This is the solution. This is how it changes in the solution. Am I still missing something? The final answer is the focus. So whether it's major or minor changes things. And let's see, this is the correct answer, so I'm good, I can move on. What's one last thing? I guess if the other difference is if it was in this case, you would need to look at this distance to get A. So instead of going left and right, it's just always the bigger one, okay? So what I'd recommend is that if you're still having trouble with this is the only question I've made for the review, and I'm not going to do another one here. We did tons of these. We really did a lot of these in the unit itself. So you can actually just watch those class videos, right? They're all labeled, so you can go find it and watch it on YouTube or whatever, right? It's in comic sections. Or just look at the notes and try to figure it out from that, okay? If you still are stuck, tomorrow or the next day, send me a message. I can go through another one with you, okay? Just let me know. Let's do the next question. The next question, I love them because I think they're very easy and students do really well on them too. Let's just try to figure out what we're being asked here. You're given the equation of an ellipse in general form. So this is the ellipse in not standard form. What is the equation in standard form? So what we need to do is you need to know what the standard form of an ellipse is. So I've given those as tables before. You can find them on a formula sheet. But we're trying to get this form. All right, this is what's called the standard form of an ellipse. So we need to force this equation to be in this form. Let me just say, if it was a hyperbola, for example, maybe that would be a good question for me to ask you on a final, maybe a hyperbola. A hyperbola has a slightly different form. It looks like this. It looks basically the same. some of you might actually remember what the difference is. Yeah, Mohammed, I had a feeling when I looked up I'd see it. There's a minus in the middle. That's the only difference between a hyperbola and an ellipse is the minus in the center. So just something to think about. It actually, the work still works the same way, but just something to remember. Let me show you how you do this. I'll write out the steps so that you can remember or follow it if you get stuck on the final. The first step is always the same. You're going to group your x's and your y's. All the terms with x in them and all the terms with y's in them. Thankfully, in this particular question, they're already grouped, but that won't always be the case. So I wanted to keep this step there just in case. You'll see here that the x values are together, the y values are together. So if they were not, I would have moved them so that they're grouped up. I didn't have to do anything for this step. The second step would be factor, and what are we going to do is factor out the constants in front of each group. Don't factor out x's, just factor out a common factor for a number. What I mean is, for example, this first one, take out a 4. There's a 4 common, it'll leave x squared plus 4. And for the next one, there's a common 9 that you should see. In the y group, there's a 9 in common. That leaves this. Does anyone remember what the third step is? 9y common. Yes, you're right, Ibrahim, but I'm saying factor out the constants, because if you factor out the y, you're not going to be able to solve it. Because the next thing we need to do, I did forget the x, thank you, Zara. That would have been bad. We can't do the next step unless we keep the letters where they are. The next step, if you remember this from when we did it, we did quite a few examples on this, we need to complete the square. And from this point on, in fact, this entire question, you're just following the recipe, okay? How do you complete the square, you may ask? Let me review it. It has to do with the brackets. You'll keep what's in the brackets, leave some space at the end of the brackets, and we're going to put a third number in there to make it what's called a trinomial, a perfect square. We need to figure out what number is going to go there. You might remember you take this number, you divide it by 2, and you square that number. 4 divided by 2 is 2, squared is 4. And then we can't, let me just do the rest. This number divided by 2, and then that number squared. 2 divided by 2 is 1, squared is 1. We need to have both sides the same number so it can be equal, I think. Yes. Yes. So we can't get this for free. We can't just add numbers in to the left side and just change it. We need to do the same thing to the right side. So the way that this works is we need to take 4 times 4. We've actually added 16, right? We added this mysterious extra 4, but it's inside a bracket with a 4, so we actually added 16. So just so this is clear, I'll erase this after. The 4 times 4 is actually what I added here. And in a similar way, the 9 times a 1 is what I need to add to this side. All right? I'm going to erase a lot of that, but I just wanted to make sure that it's clear to you why I'm adding a 16 and a 9 and not a 4 and a 1. Let me know if I need to clarify that anymore. But that's what we need to do to complete the square. The next step you might remember, I'll just call it a simplify. We need to take this middle number, divide it by 2. So x plus 2, all squared, plus 9, y. Take this number divided by 2, it's a 1, so y plus 1, all squared, equals 1 plus 16 plus 9 gives 36. Wait. Yes, it's 11. I don't know how I got 1. It's 11. It's been a long term. The right side has been 11 this whole time. I think I was just focusing on something else. Some students, you might wonder why this becomes this. And I'll show you just on the side. I'll erase it, but some of you get confused. So think of it like this: x squared plus 4x plus 4. If you factor that, what two numbers multiply to make 4 and add to make 4? It's 2 and 2. And they're plus. So if you simplify that, you end up with x plus 2 all squared, because there's 2 of them. And yes, Zara, we will divide by 36 now. So this x plus 2 all squared is why we can go directly to this. The rule, though, the pattern, is you can just take the middle number, divide it by 2, it'll always give you this answer. So you don't need to do all that work, you can skip the steps. But yes, the final step, which Zara caught, I'm glad that she reminded me, you divide by the right side. Just divide by the number, divide everything by the number on the right side. That gives you x plus 2 squared. 4 divided by 36 gives 1 over 9, so 9 on bottom. 9 divided by 36 is 4, so 1 over 4. And then we have a 1, we have our answer. How do we know we have our answer? Well, because it's in the correct form. Let me erase this out. Oops. We know that this form matches perfectly with this form. So we've done what we expected to do. And if I was to graph that, I would get an ellipse. So Mohammed's, 4. If you're not sure where those numbers came from, remember I'm taking the 4, I'm dividing it by 36. That gives 1 over 9, which is why I get this 9 on bottom. Just like I had a 9, I divided it by 36, that simplifies to 1 over 4, which is why it's 1 over 4 over here. You doing okay? Are you feeling like some of this is coming back to you? You're happy that you came to class, you're glad you're getting some review. All the formula we need will be given to us. Yes, everything's already on D2L. So there's no reason why you can't just go on to D2L and grab the formulas from there, okay? I'll be giving you an extra formula, but an extra formula sheet, but everything you need, you can already access. On the test, this was written, I think, earlier, but you're allowed to use your notes, but you're not allowed to use a phone. You can only use a phone to record yourself. So you'll have to figure out some way to access your notes. You know, you can have it if you print them all or have your notebook available. Whatever you need, find some way to have your notes, but you can't use your phone. You can't have your phone in front of you while you're doing this test. All right, and let's double check my work. Yes, I'm correct. So we're almost done. Can we have a sibling? It's not a phone. No, you had to do it on your own, but that's hilarious. And I'm glad you asked, because at least you made me smile. Can I have my smarter brother tell me how to do this, please? All right, let's do the next question. I don't want to run out of time. What is the equation of the graph shown in terms of sine? Also, what is the equation of the graph shown in terms of cosine? 2 questions. On the final, I would only ask 1, but let's see what we have. Really, what we need for sine, it needs to be this form. And for cosine, it's the exact same except with cosine. What is the amplitude, A? We look at this. I cut it off by accident. Let me write these in. These are the numbers we're supposed to have. So that was my mistake. The amplitude is not 2. The amplitude is 3. Can you mute yourselves? Yeah, I will mute you. In fact, I don't want to hear you. The only thing that will be going on, you'll just have your videos on and I'll see the space. But yeah, mute yourself. That's our amplitude. What's our period? Well, this one students tend to have some trouble with, but the easiest way to find period is to just find two of the same points on the graph. I would choose this one and this one because it gives me directly pi over 3, 4 pi over 3. You could choose any 2 points on the graph as long as they're the same point in the cycle. So you could choose these two and subtract them. You could choose these two and subtract them, which is definitely the smart choice. You could choose these 2 points and subtract them. So you'd take 3 over 2 and 1 over 6. You'd still get 4 pi over 3, and so on. But the easiest way is the way that I showed you. Next is displacement. I'm just going to call it D. How do I get displacement? Let me remind you what the shapes are. Because, yeah, if Mohammed, you're saying you're getting mixed up, I'll help you out. Let me just move this somewhere else. If you're confused, the best thing you should do, because students mix these up, right? You have sine goes like this, and you have cosine goes like this, okay? I mean, that's a pretty awful graph, but you get the idea. If you want to know which one's which, take your calculator, just start with sine, put sine 0, okay? Just put sine 0, press enter. What do you get back? 0. So the start of a sine graph is at 0, 0. That's the one. That's your sine. If you put cosine of 0, cosine of 0 is 1. So it starts at 0, 1. It's the one that starts up high at 1. So the rest should follow from that. One from the start and second from the numbers. Not sure exactly what you mean. I'm just going to, maybe I'm missing, like sine is 0. And the cosine is 1. Yeah. So sine, just the y-intercept is at 0 here. For cosine, the y-intercept is at 1. And that's what you go by. Yeah. So let's not make a long story longer. For sine, I'm looking for this point. Let me make it blue. For sine, I'm looking for this point as displacement. So some of you have said, let's see, some said negative pi over 6. That was correct. Displacement is negative pi over 6. Or you could have started here, which would be a bad choice because it's way far away and it's more complicated numbers, but you could choose it. It is not wrong. It's just less likely that you'd want to choose that one. Okay? So now that I have A, P, and D, I need to find my values, right? Because I'm really trying to figure out A, B, and C. So let's do that. A is easy. A is going to be 3. B, well, let's remind ourselves, period is 2 pi over B. Just rearrange that. B is 2 pi over P. I'm going through this quickly because I've done this before. Period, yeah, no problem, Zara. So let me finish this calculation and then I'll go back how I got period, okay? So I already know what period is, and I'll review it how I got it in a second. It's 2 pi over 3. If you divide this, just take your calculator, be very careful, divide those out, you get what? I'm curious what you get. The answer is 3 over 2. But students always mess this up. The pi's cancel. It's 3 over 2. Make sure when you set it up, I would say 2 divided by, and then use brackets 4 over 3. Zara, the way that I got period, and it's the same for sine and cosine, just look for 2 points on the graph that are at the exact same point in the cycle. So what I mean by that, I chose this. I started at 0, and then look, I go up, down, back up. It's starting again at that point. You see that, right? That would start the cycle again. The story would start again. I need to know what this distance is. Whatever this is the period, which in this case is 4 pi over 3. Okay? That's our period, 4 pi over 3. I can read it directly from this. You don't need to choose those 2 points. You can choose any 2 points that are equal, but it would be more work. All right? In order to choose 2 more, you'd have to choose this and subtract them. So I hope that's a little bit more clear. So what I just solved for was B, just to remind you. I have A and B, now I need C. How do I find C? I find it from displacement. Displacement is negative C over B, which I saw in the chat earlier. If you rearrange this, C equals negative B times displacement. So just put those numbers in. Negative, what's B? It's 3 over 2, I just got that. Displacement is negative pi over 6. And if you solve that out, I can just do it by hand. This is 3 pi over 12, or in other words, pi over 4. So it's a little bit messy. I might have ran out of space just a little bit there, but I hope it's clear. We have A, B, and C. We can write our sign. 3 sine 3 over 2x plus pi over 4. And that is that. Okay. Mohammed, can you leave? Yeah, of course. After we find cosine, if the rest is clear, no problem at all. So let me just quickly recap what we did and how I knew what to do. First things first, you need A, B, and C. That's the whole point of the question, to find A, B, and C, because we just put it into our formulas. You get A, B, and C from amplitude. That gives you A for free. B comes from the period. We have a formula for it. It's very simple. It's right here. And then C comes from displacement and B. The only trick is knowing how to find period and displacement. So just be careful. We need to find cosine. The only difference is displacement. Displacement will be different. So for cosine, where do we look for displacement? I'm going to look right here. Why do I look right there? It's because compared to this point on the cosine graph, it's been shifted by a positive pi over 6. Yes, Zara, the only difference for cosine is D. So I'll write that down. Just so that it's clear, okay? By the way, I would never ask this whole question on the final. I would ask either sine or cosine. So it's actually 2 questions. We did sine, now we're going to do cosine. The displacement for cosine. For cosine, the displacement is what? It's still going to be, wait, I haven't written it down yet. Oh yeah, it's pi over 6, sorry. Pi over 6. Now I just need a new C, everything else is the same. So displacement is negative C over B. C is still negative B times D, but it's the new D. So negative 3 over 2 times the new D, which is pi over 6. And that would simplify to, negative pi over 4. So I'm going to try to make some space here. Oops. It didn't work as planned. Sorry. Okay. So Ali, this is the one you're sure of, and Mohammed is the opposite. It's amazing how students find different things easy and different things difficult. But let me finish my answer here, and we'll figure out what's up. A cosine B. Where's B? I just looked back up top. 3 over 2 x minus pi over 4. So let me color code this here. I'll just go through it one more time. A is the same for both. B is the same for both. So when I found A, you'll notice it's the same for all of our equations. B, same story. B is there, B is there, B is there. The only difference is C. And I needed to solve C twice. So Abdal, you said, if you have time when you finish unit 5, can you explain one more time about how we get the angle again? The first question is I have no problems with units 4 and 5. Yes, actually I can go back and get the angle. Actually, I'll do the rest of the sheet first because there's only one question left, and then I'll go back to that. Amplitude is 3 because it's not clear, but you'll see 1, 2, 3. The amplitude is this. Okay. Are we okay with this question? I can go through any of it again. Obviously, I can't go through it later. So if you have specific questions of this question, Unit 4, this would be the time to go through it. I've done ones like it before. We've done the equation from the graph for sine. We've done for the equation from the graph for cosine. They were done in the unit themselves. So if you need more review, just go back and you can watch those. Okay? Hopefully it's okay. The last question, and again, Mohammed, if you need to go, it's been real, and I'll see you on Saturday, okay? Feel free to leave at any time. So this question is the equation of a tangent line and a normal line to the graph, and we're given a point. So the steps are always the same. I always give the same steps. First step is to find the derivative, which I'm going to do. 6x minus 3y squared. This gives a y prime. Minus, okay, now this is our product rule, and we have to be super careful. There's a minus in front, which means we need to open a bracket before we do our product rule. And we'll be fine. So the derivative of the first one times the second one, minus the first one times the derivative of the second one. Notice that pops out its own y prime. Equals, not 5. So many students write 5 here. It's not 5 because you need to get the derivative of that, which is 0. Some students make that mistake right off the beginning and it messes up the whole question for them, okay? So just be careful. Now what do I do is simplify this. So I have 6x minus 3y squared times y prime minus y squared plus 2xy y prime equals 0. And I'll keep track of my y primes. The whole point of the question right now is to solve for y prime. What do I need to do now? Bring everything that doesn't have a y prime term to the right and factor everything out for the y prime. So what do I have? I have y prime outside of negative 3y squared plus 2xy equals negative 6x plus y squared. We've done this before, many times. This is just slightly more complicated than some of them, but I wouldn't say it's difficult. You should have been able to do this for the test. That means that y prime is negative 6x plus y squared over this. That's our first step. Are we feeling okay so far? For those of you that are still conscious, alive, surviving. So the first bracket confused you. The only reason I did the brackets here, and they are crucial, is because I'm doing a product rule on this because you have x and a y. This whole step here is a product rule. If you don't use brackets, notice it's minus that product. Up on top here, it's a minus the product. you have to do the minus of everything that comes after. And so if you don't put brackets in, you're going to mess it up. So let me just make it clear here. I'm just going to say use brackets for the product rule. If you have a minus in front, definitely use brackets. In fact, I'll make it red so that you don't miss it. Okay, so besides the first bracket, I'm assuming that everything else is okay. I'm going to make some space for myself because this ends up being a pretty big question. The second step is always sub in your values. But we have x's and y's, so we need to sub in x and y. In this case, x is 0 and y is negative 1.71. That's from earlier in the question. It looks harder than it is. It's actually not that bad. So what's our y prime going to be? It's going to be negative 6 times 0, so it's going to cancel. And this is negative 1.71 all squared over negative 3, negative 1.71 squared plus 2, 0, negative 1.71. These numbers are a little bit ugly, but on your test, I'm giving you a difficult one now, so you have a lot of different skills you can cover, but the question on the final will not be so hard. Okay, I'm telling you, it will not be as long as this. I'm just giving you a longer one now for ultimate practice. These zeros cancel. And if you multiply this out, what you get for y prime is actually very simple. It's negative 1 over 3. What this means is that the slope of the tangent is negative 1 over 3. Okay? Our next step is to use y equals mx plus b. Sub in y and x again. We should solve this question in 1 minute. Yeah, if you're lucky. I'm going to sub in y and x again. 1.71, put my slope in, put my x in, my b. There's a 0 here, so this makes it very easy. B is negative 1.71. That means my tangent line is this. I've done so many of these that I'm actually I'm really tired of them. I'm so sick of them. But students are still messing them up. This one is the tangent. Yes, it is. And I made a note here. This is M tangent. This is the tangent line. I'll make it crystal clear. I'll even put a little note that this is the tangent. The next step, or the last step, I guess, is I'm going to get the normal line. So in order to get the normal line, first things first, I need the slope of the normal line, which is the negative reciprocal, which is 3. I will upload this, what I've written on, and I'll upload the video. Yeah. So get the reciprocal, LE, but remember negative reciprocal. Take the 1 over 3, flip it over, and change the sign. The rest is the same. You still do y equals mx plus b again. Put in y, it's still negative 1.71. Put on our slope of the normal line, which is 3, and everything else comes out. It actually ends up being the exact same, but it's not always the case. And then substitute everything in. I'm going through it quickly because we've done this before. You can watch the video as many times as you need to figure it out. And this is the last thing. Is the normal. So I'll just complete the story here by writing the tangent. We're looking for the line here. You don't need to write this. I mean, you wouldn't need to solve this yourself. The tangent would be this. And then The normal line would be this. If I was to graph it on Desmos, that's what it would give me. Now, again, this is not okay for multiple choice. I would either ask the tangent or the normal. It looks like a lot of work, but if you just do one or the other, it's much shorter, okay? I would ask the tangent or the normal, and the question will not be so long. The formula itself, the equation itself will not be so bad. It'll be shorter. Zada, you said, sir, you have a question? Zada? Zada? Overall attendance. I honestly don't know how students see their own attendance. You might have to ask another student for that. That's one thing I've never actually had to check for another student. So I don't know, I'm sorry. I don't know. I'm just saying I don't know. It should be in, yeah, it should be in PeopleSoft. Before I get into personal issues, I'm just going to say, I'm going to stop the video here so that anyone who wants to watch this later for help can watch it. So I'll post this online, and you can check the answers on D2L as well. Thank you for watching. See you later.